Hello everyone. So I am Vishakha Pandey. I am PhD third year electrical engineering student. I am working on antennas, mostly on leaky wave antennas. I am trying to solve a problem of open stop band there. So I will be your teaching assistant for electromagnetic theory E69, and today we will be trying to solve assignment 1. So I'm very sorry that my laptop got crashed and I couldn't right now I won't be able to upload uh, the assignment 1 live interaction that we had. I'm sorry for that, but I will right now I'm recording this video so that we can have one assignment 1, and I can tell you how to solve assignment 1. Okay. So assignment 1, question 1. So first question here is, given vectors A is equals to ax minus 4ay plus 3az and b is equals to 5ax plus 2ay minus 6az. Find the value of modulus of a minus b. Alright. So it's a simple vector subtraction question. It's two vectors are given to you and you have to subtract them, and then you have to find the magnitude of the subtracted vector. Alright, so it's a pretty simple question here. Now let's try to solve this question. Yeah. Okay. So A is given as ax minus 4ay plus 3az. B is given as 5ax plus 2ay minus 6az. So modulus of A minus B. So let's subtract this. So ax minus 5ax, that is minus 4ax, minus 4ay ay minus 2ay, that's minus 6ay plus 9az. So now let's try to find out the magnitude of this vector. So the magnitude will be 4 square plus 6 square plus 9 square, that is equal to under root of 133, that is 11.53. So the answer here you will be writing 11.53. Alright. Let's try to solve the second question. So the second question here is, given A is equals to minus 6ax plus 3ay plus 2az, the projection of A along AY is. Alright. So here the question is given that a vector is given. Alright. A vector is given and it is asking that what will be the projection of A along AY. Alright. So this vector has all the three components ax, ay and az. The question is pretty simple. It's asking the projection of A along AY. So let's try to solve how we are going to solve this question. So for this question, we need to do the dot product of A and AY, and then we can find out the projection of A along AZ. So A vector is minus 6ax plus 3ay plus 2az. So the projection of A along AY will be A dot AY is equals to 3. So answer will be 3. Okay. Now let's go to the third question. So here the third question is for 1 point. The third question here is, at Cartesian coordinate point P is equals to 3, 4, 1, which of the following statement is correct about cylindrical coordinate system? Okay. So this is the question. For this question, we have what is given to us. We have given a point P whose Cartesian coordinate is given to us. Okay. So Cartesian coordinate is given, and then it is asked that what will be the cylindrical coordinate system, how this point P can be written in cylindrical coordinate system, and which of these will be true. Okay. So for cylindrical coordinate system, we know that for cylindrical coordinate system, the radius of the circle is centered at the origin and passes through the point. Alright. So here point P is 3, 4, 1. So the rho will be equal to under root square of 3 under root of 3 square plus 4 square. That is uh, the Cartesian coordinates for x and y. So 3 square plus 4 square under root of this value will be equal to the rho. Rho here is the radius of the circle which is centered at the origin and passes through the point P. Okay, that is, so rho here we got is equals to 5. So the answer here will be 5. Okay. So now let's go to next question. If you have any problem, if you still find any issue with the explanation, you can put it in the comments and I will try to answer them as much as I can. Okay. Let's go to the next question. So the next question is 2-point charges Q1 is equals to minus 5 microcoulomb and Q2 is equals to 2 microcoulombs and they are placed at 3, 2, 1 and minus 4, 0, 6 respectively. The force on Q1 due to Q2 is. So the first thing that we have to check is both Q1 and Q2 are of different sign, isn't it? Q1 is negative, Q1 has a negative charge and Q2 has a positive charge and they are placed at some position, two different points, 3, 2, 1 and one is placed at minus 4, 0, 6. So the first thing we know that Q1 and Q2 will be having an attractive force in between them, isn't it? They will be having attractive force between them since their sign are different, opposite to each other. Okay. For the next part, let's go and try to solve. So yeah, so let's take Q1. We have taken Q1 and Q2 in a space. Okay, and R here is the separation between Q1 and Q2. So R will be equal to, let's put the Cartesian coordinates here. So that is minus 4, minus 3, 0, minus 2, 6, minus 1. Okay. That is x1 minus x2. Sorry, x2 minus x1, y2 minus y1, z2 minus z1. That will be the separation between Q1 and Q2, the distance between Q1 and Q2. Okay. So here the vector r will be minus 7ax minus 2ay plus 5az. So this is directed from Q1 to Q2. Now since Q1 and Q2, as I have already told you, since Q1 and Q2 have opposite signs, the force on Q1 due to Q2 will be attractive. And since the r vector here, we can see that it has all the three axes in there. That is ax, ay and az. All the three coordinates, Cartesian coordinates are there. So it is directive in x, y and z direction. All the three directions. It is directive in all the three directions. Okay. So now let's go to question number 5. Yeah. So the question number 5 here is the electric field intensity due to point charge Q is. So it's a pretty simple question here. A point charge Q is given in a space and it's asked that what will be the electric field intensity due to point charge Q. So let's see the options. The first option is outward radially directed, magnitude proportional to the charge and inversely proportional to the square of distance. Okay. The second option is inward radially directed, magnitude proportional to the charge and inversely proportional to the square of distance. Option 3 is outward radially directed, magnitude proportional to the charge and distance. Fourth option is inward radially directed, magnitude proportional to the charge and distance. Okay, so let's see the answer. So the electric field intensity due to a point charge Q. So here the point charge Q is positive, isn't it? So if a point charge Q is positive, it will have a electric field intensity radially outwards. Okay, to infinity. it will have electric field intensity radially outwards toward till the infinity. Alright. Another thing is electric field intensity here has a formula of 1 upon 4 pi epsilon naught q upon r square with a direction of r. So here we know that electric field intensity will be directly proportional to the point charge. Okay, and the electric field intensity will be inversely proportional to the square distance. Okay, so this will be the option, this will be the answer though. So option A will be the correct option. That is, it will have the electric field intensity will have outward radially directed. It will have a magnitude proportional to the change charge and inversely proportional to the square of distance. Okay. Now let's move to the question number 6. So question number 6 here asks the angle between two vectors. A is equals to 3x plus 4ay plus az and b is equals to 2ay minus 5az in degrees. Okay. So the question here is very easy. It's simple arithmetics for vectors, two vectors. Okay. So first vector here is given as A and second vector as B. And we have to find out the angle between these two vectors. Alright. So let's see. So two vectors are given. A is equals to 3x plus 4ay plus az. B is equals to 2ay minus 5az. Now let's take as theta is the angle between A and B. Then vector A dot vector B will be modulus of A into modulus of B cos theta. Now cos theta is equals to A dot B upon modulus of A into modulus of B. So now let's do the dot product and then find out the product of modulus of A and modulus of B. So I hope that you know how to do the dot product of two vectors. So this is how we do it, and the answer we got here is 0.1093. So here cos theta is 0.1093. So let's do the inverse of cos so that we find out the theta here. So theta will be equal to 83.73 degrees. So here question is asked for the angle in degrees. So here the answer will be 83.73 degrees. Okay. Now let's solve question number 7. So question number 7 here is the vector A is equals to yax plus x plus z ay and point P is minus 2, 6, 3 are given in Cartesian coordinate system. The vector A at point P in cylindrical coordinate system is. Okay, so it's a question where a point P is given with minus 2, 6, 3 as its Cartesian coordinates. Okay, and it has been asked that the vector A at point P in cylindrical coordinate system. What will be the point P will be in cylindrical coordinate system for vector A. Okay. So this is the question. So if you know how to convert Cartesian coordinate system into cylindrical coordinate system, this question won't be very tough for you. So here vector A is given as A is equals to yax plus x plus z ay at point P is equals to minus 2, 6, 3. So let's put these y, x and z from point P. So here we will get 6ax plus x plus z, that is minus 2 plus 3, that is 1 ay. So now we have vector A at point P. So vector A at point P is 6ax plus ay. Now in cylindrical coordinate system for vector A will be written as this is the generic term for a vector in cylindrical coordinate system. That will be a rho, a phi plus az unit vector of az. Okay, so A rho, A phi, AZ, cos phi, sin phi 0, sin phi, cos phi 0, 0, 0, 1. So this is the how we convert uh, simple two vectors from Cartesian coordinate system to cylindrical coordinate system. Okay, one vector from Cartesian to cylindrical coordinate system, we use this kind of this formula. So here we will write y x plus z 0. So what it will become is a rho is equals to y cos phi plus x plus z sin phi. Again a phi will be minus y sin phi plus x plus z cos phi. A z will be 0. Since now we know that x is equals to rho cos phi and y is equals to rho sin phi. This is how we convert the Cartesian coordinate into cylindrical coordinate. So x will be rho cos phi and y is rho sin phi. So here let's put the values of x and y as the cylindrical coordinate system. So we will get a rho is equals to rho sin phi cos phi plus rho cos phi plus z sin phi. A rho will be minus rho sin square phi plus rho cos phi plus z cos phi. Okay. Now we know at point P minus 2 comma 6 comma 3 rho will be under root of 6 square plus 2 square, that is under root 40. Phi will be tan inverse 6 upon minus 2, that is tan inverse minus 3, that is equal to rho is equals to tan inverse of minus 3 and here z is 3. Now substituting all these values of rho, phi and z into the expression of a rho, a phi, we use this. We use the fact that sin phi will be 6 upon root 40 and cos phi will be minus 2 upon root 40. Okay, we found out this from this Cartesian coordinates. Then a rho will be, now put all these values. Okay, and we got a rho equal to, put all the values, we have found the value of rho, we have found the value of sin phi, cos phi, again sin phi. Let's put all these values and we got a rho equal to minus 0.9487. Similarly, for a phi, put all the values that we have already got, rho cos square phi minus rho sin square phi plus z cos phi. So put all these values, we got, yeah, put all, sorry, this is not a 2, this is z sin phi. Yeah. So again we got, yeah, so we will put all these values here and we will get the value of a phi. So we got the value of a phi. We already know that the value of az is equals to 0, isn't it? So the value of vector a will be minus 0.9487 a rho minus 6.008 a phi. Sorry, here it's a phi minus 6.008 a phi. This is the answer. Now let's go to question number 8. So question number 8 here is given that 2-point charges Q1 and Q2 are located at 1, 2, 0 and 2, 0, 0 respectively. If the total force on a test charge at a point P, the point, the Cartesian coordinates of point P is minus 1, 1, 0 have no y component, then the relation between Q1 and Q2 is. So let's try to first understand what the question here means. So the question here says that there are 2-point charges Q1 and Q2. Alright. So these two will have their own electric field intensity. It will have their own force. Okay. So now a test charge is placed at point P equal to minus 1, 1, 0. And this test charge now experiences a force due to Q1 and Q2. Okay. Now this this force does not have any y component. So now it is asked that what will be the relation between Q1 and Q2. Okay, so it's a pretty simple question. First we have to find out the force of test charge. Let's take it as Q. So the force of test charge Q due to Q1 and Q2. Alright, and then when we get that force, then we can equate it to, then uh, then for the y component, we can equate the y component of that force to 0, and then we can find out the relation between Q1 and Q2. Alright, so let's try to solve the question. So yes, for 2-point charges Q1 and Q2 are given. Q1 has a coordinate system 1, 2, 0. Q2 has a coordinate system of 2, 0, 0. Sorry, here it's a 2. And point P is minus 1, 1, 0. Alright, let R1 and R2 be the vectors from charges Q1 and Q2 respectively to the point P. Okay, then R1 will be minus 1 plus AX plus 1 minus 2 AY plus 0 minus 0 AZ. So R1 will become minus 2 AX minus AY. Similarly, R2 will be minus 1 minus 2 AX plus 1 minus 0 AY plus 0 minus 0 AZ. Okay, so R2 will become minus 3AX plus AY. Now, the electric field at P due to charge Q1 will be E1 equal to 1 upon 4 pi epsilon. Let's put it in the formula. E1 equal to 1 upon 4 pi epsilon naught Q1 upon R1 square and the unit vector of R1. So that is 1 upon 4 pi epsilon naught Q1 upon R1 square. So R1 square here will be under root of 2 square plus 1 square. So that is 4 plus 1, that is under root of 5. Alright, and the unit vector of R1, that is R1 vector upon magnitude of R1 vector. So the magnitude of R1 will be under root of 5 and the R1 vector will be minus 2x minus AY. Similarly, the electric field at P due to charge Q2 will be, let's put it, we know the value of R2, we know the formula, we will put all the values in the formula and we will get this. Okay. Now E1 will be E1x AX plus E1y AY. E2 will be E2x AX plus E2y AY, since there is no Z component. Now it's written in the question itself, it is written that there is no y component of the force or the test charge at point P. Then we know that E1y will be equal to minus of E2y, because the total electric field intensity will be equal to E1 plus E2. So we somehow need to cancel E1ay from E2ay. So which means that E1y will be equal to minus of E2y. Okay, so this is the same repeated. Yeah, so now we already know the y component of E1 and the y component of E2. So we will equate that. That is minus Q1 upon 5 root 5 equal to minus Q2 upon 10 root 10. So we got that Q2 is equals to 2 root 2 Q1, and this will be our answer. Okay. Now let's try to solve question number 9. Question number 9 here is for 2 points. Okay. Alright. So here question number 5 states, here question number 9 states that 5 identical 15 microcoulomb point charges are located at the center and the corners of square of a square defined by -1 less than x comma y. Sorry, yeah, uh, sorry, I messed up the. So now let's try to solve question number 9. So question number 9 states that 5 identical 15 microcoulomb point charges are located at the center and corners of a square defined by -1 greater than x comma y less than 1. Z is equals to 0. The force on the 10 microcoulomb point charge at 0 comma 0 comma 2 is. Alright, so here a square is defined where x and y are in between -1 to 1. Okay, and 5 identical point charges are given at the corners of these squares and one at the origin. Okay, and it's asked that what will be the force on 10 microcoulomb point charge. Okay, so it's a pretty simple question. Here what we have to do is, first we have to find out the individual forces on this 10 microcoulomb. The individual forces due to the 15 microcoulomb point charges which are located at the corners of the square, and then sum it up, which uh, which will be equal to the total force on this 10 microcoulomb point charge. Alright, so let's try to solve this question. So, yeah. So let QP be 10 microcoulomb and Q1, Q2 and Q4 be the charges at the corners of the square and Q5 be that of the center of the square. Okay. The force on the QP will be uh, due to Q1 will be equal to F1. Let's put it in the formula 1 upon 4 pi epsilon naught Q1 QP upon under root of 2 plus 2 square. This is this is the distance between the q1 and qp. Okay, multiplied by 1 upon 2 plus 2 square and the unit vector and the vector of the distance. Okay, that this is just the r1 square. R1 is, let's say, r1, and r1 is the distance separation between q1 and qp. So we have put that. Let's just use the formula. Alright. Similarly, we can find out the force by Q2 on QP. That will be again put it in the formula 1 upon 4 pi epsilon naught Q2 QP 1 upon R square, the separation between Q2 and QP, and then the unit vector. Similarly, Q3, we have to find out the force of due to Q3 on QP. So similarly we will find out F3 and F4 and F5. Now after finding out all the forces F1, F2 and F3, the total force will on QP due to all of these charges will be F1 plus F2 plus F3 plus F4 plus F5. So now adding all these forces, we got F is equals to 1.072 newtons. Alright. Now let's see question number 10. Question number 10 is linked with question number 9. Here here they have asked the electric field intensity at point 0 comma 0 comma 2. So that's it. So the force we already know due to all the charges on QP. Now the electric field intensity will be just the force divided by the charge QP. So that will be 1.072 divided by the charge, that is 10 microcoulombs, that is 10 to the power minus 5 volts per meter. So the electric field intensity will be 107.2 kilovolts per meter, and this will be our answer. So yeah, so this is, so that's it for today, and If you have any doubt, as I have already told you, if you have any doubt, you can put it in the comments, and I will try to answer them as much as I can. And even if you can't comment, we can have it in the next week. You can ask the question, the doubt that you are having in next week. And yeah, thank you.